So I'm Sim Larkin. I'm with the U.S. Forest Service Air Fire team, and I get to present some of the updates that we're doing for the map this year. And I just want to say this is the effort of many people, including Stuart Ilson in particular at the University of Washington. So I want to call out those. As has been mentioned before, this is an effort between the EPA and the Forest Service, and in particular, the Interagency Wildland Fire Air Quality Response Program, which tries to address smoke impacts during wildfire episodes and other incident response situations, such as we've been having in recent years, like in 2020. The fire and smoke map version 1, I'll go through that a little bit here and try and talk about what we were trying to do with it as it currently exists, and then I'll explain what the updates are. So here's just a couple screenshots, and it's important to note that it exists in a responsive system, so it can be seen on a desktop or in mobile. As we discovered in 2020, actually the majority of our users are coming to it on a mobile device. So there's some effort here in 2021 to really try and honor that. The objectives, of course, are to provide the enhanced air quality information, bring in those low-cost sensors in particular to try and enhance the number of locations where observations are available, and to use the best available science, including being able to QA and QC those so that they can be directly comparable with other installations of air quality measurements that are more expensive. So the data layers in the map are permanent monitors, permanent monitoring sites, temporary monitors. These are typically put out by agencies, including the Interagency Wildland Fire Air Quality Response Program, but involve sort of expensive equipment that's maintained by some group. And then the low-cost sensors. In this case, we're dealing with PurpleAir data. We also bring in fire information from the fire incident reports. These are the command teams that go out and are dealing with fire situation. They are filing reports, and so we have access to those. We can bring that information to you, as well as satellite detections of fire. So there are various satellites looking down, both polar orbiting and geostationary. These see hot spots on the ground. Those can be assumed or identified using algorithms to be fires, and so we can get early warnings of fire detections that way. And then we can get satellite smoke plumes in there. So these are observations, again, from various satellite sensors, particularly visible imagery that can be identified as smoke plumes, and those are brought in through the NOAA hazard mapping system. So all of this is observational data, and it all combines to sort of paint a picture. And it's that picture that we're trying to make as accessible and as easy to understand as possible. So let's just see how that works in an example for a second. This is from October 27th, 2019 at 10 a.m. So in this case, this is the period of the Napa and Sonoma fires just north of San Francisco. Over here is San Francisco in the Bay Area, and the fires are up in here. And you can see that at this particular time, many of the permanent monitors indicated here by circles were not really experiencing much in the way of smoke. This changed later, but at this particular instant, that's sort of what's happening. And we can, at that time, there were a few temporary monitors that were deployed, indicated by triangles here. So these are less established sites, but still a certain level of equipment. And they're starting to fill in the picture a little bit here, but not a lot. And for reference, here's what the low-cost sensor data looks like at that time. So even at, back a couple of years, a year and a half, we have a lot more of these low-cost sensors placed on the ground that are able to send back data and really sort of fill in a spatial pattern which is very interesting and informative. Additionally, we have, fire information and smoke plume extents from this period, as I showed you a couple of slides back, but this is, sort of the picture of the air quality on the ground. And if you click on any of these various things, the triangles, the circles, or the squares, you can gain more information about what it's saying and what's been happening at that particular monitor or sensor. So in this case, if you click on one of the monitors, you can gain a bunch of information, including the nowcast AQI value and a time history of the nowcast values dating back. So this is from just an example monitor taken today. And you can also gain access to the hourly concentration values, which we don't present in the AQI colors, but you can gain access to that to see what's been happening. So this is kind of where things were last year. And we were very proud of this, being able to bring all this together. And for low-cost sensors, we did much the same thing, same sort of presentation of those. So one of the goals of this year has been to really enhance the amount of information and the interpretation of this information for the user and make it just a lot more user-friendly. Additionally, we had fire information in there. And so for major fire incidents, we had, some limited amount of information, including the size, containment, and when it was updated from the National Interagency Fire Center systems. And so we tried to bring that in. Additionally, the map provides an in your area or geolocation, functionality. So if you have that turned on, there's no need for it to be turned on. The map on your browser identifies it and then starts to find information that's close to you. So this is being done primarily in your browser. There's not a lot of information being exchanged back with the servers. So we're trying to keep it all as private as possible. And the specific bits of information that we're trying to call out, and this is an example from Florida over in Cape Coral, is that, where are the nearest monitors and sensors? So here they are with respect to that blue dot. How far away are they and what are they saying at this time? Additionally, where are the satellite detections? Where's the nearest one? And are there lots of them around you or just a few? These can give you a different picture of what fire is happening, what's the level of fire that's happening. And in this case, there actually are no large-scale incidents going on at this time. So, what you're seeing is a bunch of smaller burns happening, but no large incidents were identified at this time. And then, how far away are the smoke plumes? And so since some of the smoke is coming closer, these are actually closer than the fires, but still not right on top of the person in this case. The other thing that the geolocation can do is it can provide direct access to incident-issued special smoke statements. So if one of these is applicable to your area, it would have appeared in that in your area place, but also a special banner would alert you at the top and say that there's a special smoke statement issued for your location. These are issued by smoke specialists out on the fires, managed by the Interagency Wildland Fire Air Quality Response Program and the incidents themselves. And so you can gain, by clicking on that, direct access to the smoke outlooks that they're producing, which include general descriptions of the fire and smoke, but also specific forecasts for specific locations. In doing all this, there are a number of data considerations and challenges that had to be kept in mind. So timeliness, the different monitors and sensors have different lag times before the data is available. And then time averaging. So we are using the nowcast time average, which is an identified and sort of standardized way to average multiple hours together. It equates to something like a rolling 3-hour average, although that is not exactly its definition. And what it provides is a more rapidly changing system that's supposed to mimic kind of the daily AQI in terms of its ability to be related back to health messaging. And so, this is an important aspect, and this is an important developed and established system for trying to message health effects. And so, so that's the primary messaging. And of course, we have data down at the hourly and sub-hourly now with low-cost monitors, low-cost sensors. And so, there's a question of how do you sort of compare and contrast, what's happening in the nowcast time averaging with more recent sub-hourly data. And let's see. So, other data considerations and challenges are that the low-cost sensors are, more likely to be moved or turned off or have other consistencies. So there's a lot more quality assurance and correction that you need to get into when you're dealing with this low-cost sensor data. So we are presenting the nowcast AQI levels. Those are showing a standard set of color coding and categories ranging from good up through hazardous conditions. And then they have specific health messaging that's been identified and as being important to get out to the public. In addition to these 6, we also use gray to indicate when a sensor or monitor is just simply failing to report data back and we don't know what the conditions are at that time. So these different types of instrumentation are reflected in symbology on the map. Permanent monitors are shown as larger circles. And, examples of permanent monitoring sites are, shown in this picture. This one's from Jefferson County in Alabama. And you can see that it's, it's an actual physical thing that's been developed and has an owner and in terms of an agency that is going out and maintaining it and making sure that it's calibrated and working properly. Temporary monitors are similar types of equipment, sometimes shrunk down or modified to be able to fit, on a tripod that's human carryable, and they can be deployed in various places where established sites are not available, but they are still quite expensive. And then we have low-cost sensors, which in this case, we're reading in from the PurpleAir sensors. They're very small by comparison to these other things, but their low cost means that they're able to be purchased by normal people, and they are, able to be purchased in quantity. And so there's just a lot more. So, while you get higher quality and professionally sited and professionally maintained monitors on the permanent temporary side, their higher costs limits their numbers. And also they're designed to really report in sort of hour averages and to have different systems, including cell phone systems or satellite systems to report from remote locations. The PurpleAir sensors, lower cost means that there's just a lot more of them. They report very quickly because they're piggybacking off of their owner's Wi-Fi systems in most cases. But the things that you have run up against is that you don't know exactly how they were sited and how much care the person took in siting them. You don't know about their maintenance. And so this creates more of a need for the QA/QC. So we're going to get into that QA/QC in the next presentation, but I just wanted to highlight these differences in terms of what's being presented on the map. So updates for 2021. I mentioned a few things that are considerations for us in this, one of which is that we had a lot of mobile users, another of which is that we wanted to make information just a lot more accessible and understandable to sort of the lay person who might be coming in, is just dealing with, a situation where there's a lot of smoke in their area and is just coming in trying to understand what's best for them and their family. And this is also important in light of the inclusion of the fire and smoke map in fire mode on the AirNow site. So we're expecting that to drive more people to us during these periods of smoke, as well as the inclusion in the AirNow app, which we expect to enhance in the number of mobile users that we get. So those are a couple of considerations. I'll show you how those are playing out in changes here in a second. But before I do that, I just want to mention that there's a bunch of changes that you really won't see per se. They're not visible in some sense, and that is, we're going to be updating the correction factor as explained in the next talk. But we've also rebuilt the entire back end. PurpleAir has changed their system for how they're transferring the data to people. We're taking advantage of that and the great partnership that they've been able to develop an API and have been flexible enough to take some requests on that. And so there's a bunch of changes that sort of knock on based off of that rebuilding of the back end. A couple of those are important. So one is the system's faster. So we're looking at time scales between when the data is hitting the PurpleAir data feed to when we can display it to you that are, right now we're clocking, just around a minute, but things may change. We may get more monitors, whatever, or more sensors. So we're looking at, trying to keep it under 2 minutes in any case. The other thing is that we have spent a lot of time and energy trying to shrink the size of the data package that's coming to the user. And this is in recognition of the fact that many of the people wanting to use this may be in situations where they have not that great of internet or cell phone data connection, maybe using older devices that are not as capable of handling large data downloads. And so we really want to make sure that we're serving those people as rapidly as possible. And if you're on a better system, it just means it'll work ever so much faster for you as well. So we've been able to shrink the data package by, on a per sensor basis, by about 60% so far, and we have a couple more tricks that we're hoping will shrink that even further. But that's a significant savings over the data load that we were experiencing last year. And so hopefully that shows up particularly on cell phone connections as an enhanced user experience. Okay. So one of the things we're really focused on is trying to make the map easier to understand. One of the requests we had was to create a legend that was, right there, easily accessible, and it had been buried off in a menu previously. So it is right there in the lower left-hand corner. It's shrinkable or expandable to get it in if you want to see it or get it out of your way, but it remains there, and so it's always accessible to the user right on the top now. There's a lot of work that's been going into frequently asked questions and how to update those for this year, but also how to have a system that allows us to update them even throughout the fire season so that we can be responsive to questions that we might get in. And so there's a whole new system for that that should be much faster to update. We've also connected fire information that was showing up in our, I showed you a pop-up of that before. Here's a revised pop-up. It now includes a direct link into the InsaWeb system. This is the National Interagency Fire Center's sort of main portal for information about major incidents. And so, you get the pop-up on the map like this, and you click on this, this InsaWeb link here, and you will be taken to the InsaWeb page for that fire that has just a huge amount of information within it for those that want that type of information. It also, we're hoping, will drive people to the InsaWeb site so that if they're being particularly affected by one incident, they will know where to go look. And the InsaWeb site pulls a lot of data from a lot of places, particularly the command teams that are out there, and it's updated all the time. So this is a useful resource for those that don't know it. Another thing that you'll just notice immediately is that there's just a lot more PurpleAir sensors now than there were in at the beginning of 2020. From the end of 2020, we're looking at something like a 50% increase. From the beginning of 2020, we're looking at almost 100% increase. And so this is just due to the expansion and the number of people who have purchased PurpleAirs. And so we're going to have a lot more spatial coverage, just a lot more data up on the map for you to access. And hopefully that helps, particularly in places of low data density. Another thing is that we spent a lot of time trying to revise those pop-ups. So when you see on the map that something's happening, when you click on it, what are we going to tell you? And so we're trying to make it a lot easier to find the info you're looking for. So the new landing page, when you click on a sensor or monitor, looks like this. And it provides a collection of information, but there's additional information on further panes that you can flip to within that pop-up. So in this case, it's trying to provide an overview and access to that further on information. We are highlighting the specific category that you're in this case, unhealthy for sensitive groups, and the sort of color coding of that as a hopeful trigger to people as they learn what that means for them personally. And we're also providing a short statement on what the actions they might want to take at this point. Clicking on that, or really anything on here, takes you to a pane with more information on that particular topic. But we also provide 3 sections down at the bottom here: a current tab, a trends tab, and an actions tab, each which is designed to give you specific types of information. So with the current tab, we're trying to mimic the gauge system that's shown on the main AirNow site, providing just a different way to look at the data, gives you a sense of where you are in the overall scale, as well as just providing those people who like visual representations something to grab onto. People respond to different kinds of data, so hopefully that's useful to a certain category of users. And it also provides for this continuity with the main AirNow site. We also have a recommendations pane or an actions pane. These are statements related to the specific category, in this case USG, and the specific wording and layout may get changed. We're thinking about adding in the color and the level into this pane as well. But the idea is to provide direct information within the pop-up about what this means, and then provide a link so that if you want to learn more about the overall AQI categories, etc., you can get to that directly. Additionally, we want to take advantage of the rapidly updating low-cost sensor data. I talked about this earlier in that tension between different time averaging schema. And the Nowcast AQI represents a certain goal or target that has this relationship with health messaging, but what it can sometimes not properly explain to the person is what they're looking at sort of outside their window. That's when shorter term time averages have a lot of meaning, and where the low cost sensors with their rapidly reporting Wi-Fi systems provide us access to data that might be relevant and useful to the user. So the question is how to use that shorter term time averaging to try and get at what are they seeing now, and what does that mean in terms of this broader health messaging. So we are using something called trending to try and cover this. So trending basically has a shorter term time average than the Nowcast. We are not claiming it is at the same level, but we are trying to explain that over this shorter time average period, that this is the direction that we see things happening. So, in this case, that it's increasing, and that we're headed upwards towards the unhealthy range if conditions persist. So we're using the past 30 minutes of data, the exact weighting of which part of that 30 minutes, etc. There's about 3 different systems that we're trying out, and we'll we'll be evaluating. But the goal here is to try and bridge that gap between what you see outside your window and the nowcast, so that you can understand both the health messaging from the nowcast and also potentially some of the more instantaneous behavioral sort of considerations that you might have over the shorter period. We are also looking at the addition of other air sensors. This is going to have to be done in a, under a criteria which sort of defines the parameters under which those other sensor networks can be brought in. And there's a group working on that. Any decision to bring that in will, of course, have to happen in consult with the EPA in consultation with the state, local, tribal air monitoring agencies and stakeholders. That's a lot of effort and sort of decision making that needs to get done. And so unfortunately, we're unlikely to see that really for the main body of the Western wildfire season, but we're hoping that that can be something that can get added in relatively soon thereafter. So as was mentioned previously, we have this rollout of the new version with the whole new back-end system, basically the rebuilding of everything from the ground up in some sense. We are testing the system for stability and sort of feature completeness right now internally with a small group, and then we're handing a password protected test version to our partners like yourselves in the next couple of weeks. And then we're going to take that feedback, incorporate those changes before releasing publicly. Okay, thank you. And with this, I'm going to turn it over to Karoline and from the EPA to talk about the updated correction factor.
Thanks, Zen. Let me share my screen here. Okay.
You can see it.
Great. So I'm Karoline Barkjohn, and I'm a scientist in EPA's Office of Research and Development, and I'm going to give you a quick overview of this updated correction for PurpleAir sensors on the map. And so in 2020, there was extreme smoke in many parts of the West. And so we captured a number of sites where PurpleAirs were located close to either federal equivalent or temporary smoke monitors. And we merged that into a huge data set with also typical ambient sites where PurpleAirs were co-located for about a year or more. And so from those data sets, we are building a better correction so that these PurpleAir sensors can be shown comparably on the map. So we want to build a correction that fits the full range from typical ambient up to 1,500 micrograms. We want to consider the potential influence of relative humidity, and we want to make it as simple and easy to implement as possible. And so to evaluate this model, we're evaluating the performance at each air quality index breakpoint, which is really important since the air quality index is the primary way that risk is communicated on the map. And so we're targeting keeping the bias within 10% in each bin. So for example, from good to moderate, we would want to make sure, the data right around that breakpoint wasn't always 30% high or something like that. And then we want to reduce kind of the random error in each bin as well. And so we're looking at the performance across each AQI breakpoint, and then also 500 micrograms, which is the Karoline respirator standard for outdoor workers to put on their respirator. And so the final correction equation is using this initial US-wide correction that we had built in advance of last summer. And then shifting to a quadratic fit at higher concentration, so above 343 as measured by the PurpleAir, or just over 200 as measured by a reference measurement or the corrected sensor. And so basically we fit the US-wide correction and the quadratic fit to these data sets, and the US-wide correction was the best fit from 120 to 180, that breakpoint between unhealthy and very unhealthy. And then the quadratic fit was the best fit at the breakpoint between very unhealthy to hazardous. And so we selected an equation transition point right in the middle of the very unhealthy category so that it would not hopefully influence the AQI category that the data falls into. And so how does this change our PM 2.5 estimate? You can see in black the monitor and in purple the updated correction. And I just pulled this as a nice example from Forks of Simmon in California, where we see a really wide range of concentrations over just a few days. And you can see in gray, if we were to use that old US-wide correction, you know, it worked fine under lower concentrations, but then it starts to significantly underestimate, especially above, 300, 500 micrograms. And so we've gotten a number of questions. How does this compare to other corrections on the PurpleAir map? As you're probably aware, currently the PurpleAir map doesn't apply any correction to their data, but you can select one from the dropdown and you can find more details there if you want to read more about some of their other corrections they have available. And so looking at the same time period and plotting the different correction factors that are available on purpleair.com, you basically see the LRAPA correction stands out as being much lower than the others. And on PurpleAir, on the map, it does say that you should only use that correction from 0 to 60 micrograms per meter cubed. And then you see a cluster of everything else except for the extended correction. And if you look closely, you can't really even see the old US-wide correction because it's almost entirely covered by this green AQ and U line. They're very similar, just the original US-wide correction has a relative humidity term that isn't included in any of the other corrections. And I do want to point out just this CF alt ×3 is a new correction that was just published in Wallace et al. PurpleAir will likely add it to their map since they've typically updated the map as soon as new corrections are published. And that one lines up very similarly to these other corrections. And so overall, looking at our performance by bin, we were able to reduce the bias at each of these air quality index breakpoints to within 8%. Some of the bins had much less bias, only 2%, but 8% maximum. And then that random error was plus or minus 20% on the hourly data. So we feel like this is giving us a pretty good estimate over this really wide range of concentrations. And I just want to note that it's really challenging to truly estimate the error on PurpleAirs because there is uncertainty in the federal equivalent methods and the temporary smoke monitors, especially when we're using them at these 1 hour averages. Potentially some of the high concentration sites, there may have been a little bit of distance between the PurpleAirs and the monitors. So some of that could be kind of a little bit of spatial variation in addition to instrument disagreement. And lastly, there's variation between individual sensors. A lot of that is cleaned up by having the duplicate plan tower sensors inside the PurpleAir, so we can run those checks, but there's still a little bit of variation.